We're now going to use our new definition of what an angle is and redefine the trig ratios sine, cos and tan. To do that, we're going to base it on a circle of radius r that's got a centre at the origin. Now, using this circle, we can draw in any angle we like. So I'm just going to draw an arbitrary angle here. We're going to call it theta. In this case, this will produce some coordinates on the circumference of the circle we'll call xy. Now, theta can be absolutely anything. At the moment it's an acute angle, but this definition will work for any values of theta whatsoever. So here are our new definitions of the trig functions. So sine theta is equal to the y coordinate over r, the radius. Cos theta is x over r, and tan theta is y over x. Now, first of all, these still are consistent with the definitions you will have seen at GCSE. And I'm just going to look at the sine theta definition just to convince you. So the definition we've got here is that sine theta is y over r. But you will have used to come across the definition that sine theta is opposite over hypotenuse, where theta is an angle in a right-angled triangle. But if you think about what we've got here, we can very quickly produce a right-angled triangle. And if sine is opposite over hypotenuse, the opposite side is just the y coordinates on the circumference of the circle, and the hypotenuse is just the radius of the circle, which is r. So this definition is still consistent with the SOHCAHTOA you will have learnt at GCSE. It's just we can adapt it a little bit further. Now, before we carry on, it's useful thinking about the quadrants when it comes to trig values. So for instance, the first quadrant, we know that all the x values and y values in this quadrant are both going to be positive. Now, for this idea, we can think, well, if both x and y are positive and r is positive as well, sine is y over r, so sine of any value of any angle in the first quadrant is also going to be positive. If cos is x over r, that's something positive over something positive, so that's positive. And tan theta is y over x, so that's something positive divided by something positive, so that's also going to produce something positive. So what we've essentially said is any angle in the first quadrant, sine, cos and tan will all, so A for all, produce values which are positive. Now, in the second quadrant, the x coordinates are all going to be negative, but the y coordinates will still be positive. So with this approach, we can go through the sine, cos and tan to see which ones of those will be positive or negative. So in this case, sine is y over r. Now y is still positive and r is still positive, so sine will still produce positive values. But cos theta is x over r and x is negative. So cos theta, for any value of theta in the second quadrant, will be negative. Tan is y over x, which is something positive divided by something negative. So again, that will produce something that's negative. So what we're saying is angles in the second quadrant, it's only the sine ratio which will produce something that's positive. Now we can extend this a little bit further. So in the third quadrant, we know that x values are negative, and so too are y values. Now in this case, all of our three trig ratios, well, they will all give you something negative except for tan, because you'll have something negative divided by something negative, which will cancel and give you something that's positive. So in the third quadrant, it's tan that produces positive values. And with a very similar reasoning, let's get a different colour. We know that x is positive, y is negative, And with the same reasoning, you can very quickly show that it's only cos values in this quadrant that give you something positive. Now, it's definitely, however you do it, it's definitely worth remembering which letters go with which quadrants, because that will be key to solving some problems later on. Now, to take this a little bit further, let's consider we've got an angle theta here. There will be another angle around the coordinate axes which will be very similar, and I'm going to draw it. It's this angle here which produces the same acute angle theta with the x-axis. Now, if the coordinates that our original angle produced here are x and y, then the coordinates that this second angle will produce will be exactly the same, except the x coordinate will be negative, but it will still have the same number, the same value with it involved. And in a similar way, we've got a third angle, which again is similar, which again it makes an angle theta with the x-axis. And the coordinate that this will produce on the circumference of the circle will be the same as the original one, but both x and y will be negative. Finally, there's a fourth angle which is very similar. Again, it produces an angle theta with the x-axis, and this time the coordinates will be the same, except the y will be negative. Now, because the sine, cos and tan are defined only involving x's and y's, that means that these four angles, although they are different with our definition, will always be using the same numbers in the trig ratios. So the trig values will all have the same kind of absolute value. The only difference is, depending on which quadrant they're in, will depend on whether they're positive or negative. And we'll look at an example just to illustrate this. So if you put into your calculator sine 30, it will tell you very quickly that sine 30 is 0.5. So I'm just going to draw 30 degrees there, and we know that sine 30 degrees is 0.5. Now, from now on, we're going to do some more calculations, but without a calculator. I've got a 30-degree angle in the first quadrant, but here, in the second quadrant, is a similar angle. I've still got the 30-degree angle with the x-axis, although it's in a different place. Now, as we know, this isn't actually 30 degrees. This is 150 degrees. But, with what we've just looked at, I know that sine 150 degrees is going to have the same value as sine 30 degrees. And, because I know that the second quadrant, all of the sine values are positive, I know that sine 150 degrees is going to be positive at 0.5. Looking to the third quadrant, let's consider this angle again with 30 degrees made with the x-axis. And as we know, that's not 30 degrees, but it's going to be 180 plus 30, which will give us 210 degrees. And this time, sine 210 degrees will have the same value, 0.5, except it's in the third quadrant, and only tan values in the third quadrant are positive. So sine of 210 degrees will be minus 0.5. And just to complete this off, this angle here, which is 330 degrees, again will have the same value for sine of it. So sine of 330 will have 0.5 in it, but because in this quadrant only cos values are positive, that must mean that sine 330 degrees is minus 0.5. So what we've illustrated is by using one fact, we've been able to generate 3 more trig facts without using the calculator. And actually, you could stay here all day and work out more values. You could use negative values, you could use values zero above 360 degrees, and you could keep going, providing that the angles themselves produce an angle of 30 degrees with the x-axis. You can have the same approach. So just finally, what can we say about tan minus 400 degrees? Well, to start with, let's consider what minus 400 degrees actually looks like. Well, because it's negative, it means we're going to go the wrong way round, so we're going to go clockwise. Now, once would be 360 degrees, once the way round, so we'd need an extra 40 degrees to get back. So just making that look a little bit neater. Ooh. Minus 400 degrees essentially has this position here. So minus 400 degrees has very similar properties to 40 degrees. Now, if we're interested in tan of minus 400 degrees, we can consider the quadrants, and we can consider which quadrants produce positive values. Now, as we're in the fourth quadrant, it's only cos values which produce positive values. So this tells me that tan of minus 400 degrees is going to be the same as tan of 40 degrees, which is illustrated, except it's going to be minus because it's in the fourth quadrant. So tan of minus 400 degrees will be the same as minus tan of 40 degrees.